Good morning to everyone. Okay, then we'll continue next. Salt. Generally, what is a salt? How can we define a salt? We will have sodium chloride, we can say salt. Sodium nitrate is a salt, potassium nitrate, barium chloride. We have so many salts. And how can we say it is a salt? We can define the basic definition for the salt is like this. So this is a substance which does not produce either H plus or OH minus ions in its first ionization. What is ionization? First of all, let me write the definition here. The substance which does not produce H plus or OH minus ions. On its first ionization. On its first ionization is known as salt. So, what is the meaning of first ionization and ionization? Just ionization means conversion of this or splitting of the molecule into ions. Ionization we can write like splitting. Into ions. Okay, now salt means it is a substance which does not produce either H plus or OH minus ions on its first ionization. So, we will discuss again about this first ionization. What is the meaning of first ionization? That will come later. So, till then just remember this definition. Let us take few examples here for the salt. The basic idea: sodium chloride, potassium chloride, calcium chloride, sodium nitrate, some etc. So, sodium chloride, and if you do the ionization, what it can produce? It can produce Na plus and Cl minus, and you cannot see here the formation of H plus or OH minus. And similarly KCl, and it can give K plus Cl minus ions. Again here no formation of H plus or OH minus. If I take like this some other compound, sodium bicarbonate, even though we have the hydrogen here, and if it undergo ionization, it can give Na plus HCO3 minus. Again there is no formation of H plus or OH minus after ionization of the sodium bicarbonate, hence we can say this is also a salt. So, this is the basic idea about the salt. We can define like that. We have the feel what is a salt, we know, but theoretically in the form of definition also we should know. But here we have various types of the salts that we can take. The classification of salt. So, we can classify the salts broadly in two ways. One is based on their chemical nature and based on the composition of the acid and base, the strength of the acid or base we can say. First one, based on chemical nature. And the second one, based on the strength of acid and base involved. Because generally salt can be formed by the reaction between acid and base only. So that acid may be the strong acid or weak acid, strong base or weak base, and base. So based on the strength of acid and base. So we will go with the first. This is broad classification. First of all, we will discuss about, based on the chemical nature, the classification of salts. And based on the chemical nature, further we can classify them as like this. Based on chemical nature. So they are normal salts, or we can say simple salts, second one acidic salt, third one basic salt, mixed salt, and next double salt, complex salt. Okay, na? These are the few classifications. Again, we will discuss in detail one by one. What is a normal salt, what is acidic salt, basic, mixed, double, complex, etc. Okay, these classifications. Yes, you can note it down all this. And next we have, first we will start with the normal salt. So first we will go with normal salt. The same definition we can give for whatever we have taken so far for the salt definition. Normal salt or salt means which does not produce either H plus or OH minus ions, and that it in its first ionization is called normal salt. Same definition we can write it now. It is a salt which does not produce or release either H plus or OH minus ions in any of its ionization. Which does not release either H plus or OH minus ions in any of its ionization. Again, what it means? Alten. So just now one word we have that is a first ionization. What is the meaning of first ionization there? And any of its ionization, what it means again? That also I will give you the clarity for that. Just wait for some time. You can take same examples like NaCl, KClO3, sodium carbonate, sodium oxalate, some etc. And all this comes under normal salts. So, they will not produce either H plus or OH minus in any of its ionization. Is called normal salt. And the next one, acidic salt. And what is this acidic salt? Again, you can define like this. First, I will write the definition. So, it is a salt which releases. So, previous case does not release, but here which release H plus ions except in its first ionization. So, this is very important, except in its first ionization, that is called acidic salt. Now, we will come back all these words in the first ionization, any of its ionization, and except its first ionization or second, third, so on, what it means. Let me take examples first here for acidic salt. Sodium bicarbonate, it is an acidic salt. Sodium bisulfate, yes, potassium bicarbonate. Sodium hydrogen phosphate, some etc. This comes under acidic salt. Then how to identify whether it is a normal salt or acidic salt? The definition. Normal salt means it does not produce H plus or OH minus, whatever the ionization, but acidic salt except first ionization, it can produce the H plus. Let us go with sodium bicarbonate. Let me take sodium bicarbonate, the example. Just you do the ionization in the first ionization. This is first ionization. What happens here? It will split as Na plus and HCO3 minus, isn't it? When you take sodium bicarbonate and when you add to the water, first ionization Na plus and HCO3 minus. Then after, will the reaction stops there itself? No. Further we have HCO3 minus, and this HCO3 minus can split further. It can give or it can undergo further ionization, that we can call second ionization. There is a possibility first ionization, second, third, so on, depends on the number of ions present, the type of the salt. Yes, and here it can give further ionization, it can split as H plus and CO3 2 minus. Now, come back to the definition. Acidic salt, except in its first ionization, it releases H plus ion. Now, see, this is the first ionization. In this first ionization, there is no generation, there is no production of the H plus ions. But whereas in case of second ionization, H plus is released. Hence, we can say sodium bicarbonate is the acidic salt. Now, come back to the previous definition, normal salts. If you take sodium chloride or sodium carbonate or sodium oxalate, few of the salts. For example, if you go with sodium carbonate, what happens here? In its first ionization, first it will give Na plus salt ion, then Na CO3 minus. Again this Na CO3 minus in its second ion. Let us assume this is the first ionization and this is second, but generally we will write it together. We assume like this. Then you will get Na plus again CO3 2 minus. See, any of its ionization, either it may be first one, second one or third one, does not matter. whatever the type of ionization, any of its ionization, there is no releasing of H plus or OH minus, and that is called normal salt, and all these. Okay, normal definition we gave generally salt. Salt, it may be normal salt or acidic salt. So, what is the salt definition we wrote down here initially? The substance which does not produce H plus or OH minus ions on its first ionization. Again you can check it in case of acidic salt. Anyhow, normal salt case, nowhere there is a production of H plus and OH minus, but in case of acidic salt, if you see, in its first ionization there is no generation, but in the second ionization it is. So, it may be the H plus or OH minus may release after the first ionization in the second, third, fourth, so on, but it should not release in the first ionization. That is it. That is called salt. Okay, na? Yes. So, this is about the acidic salt. We will take one more example of the sodium hydrogen phosphate. Here Na2 HPO4, if you take like this now, and here if you do in the first ionization, it will give Na HPO4 minus plus Na plus, like this, and again there is no releasing of H plus in the first ionization. Again second, again the sodium hydrogen phosphate further can split, further ionize, and it will give H plus PO4 minus, and again it releases Na plus. Again there is a chance further to ionize, and this HPO4 minus further ionizes, and it can give PO4 3 minus and H plus. Now see, this is first and this is the second and this is the third. Yes, Nana? Sorry, HPO4 2 minus. So, here in the third ionization H plus again released, at least either second, third, fourth, does not matter. So, except in the first ionization, if H plus is released, then we can say again this sodium hydrogen phosphate is the acidic salt. That is about acidic. Next, third one, basic salt, just quite opposite to the acidic salt. Are you making the note? Just I am screening, passing the screen. I don't know whether you are copying or not. No one is asking. రాస్తున్నారా నోట్స్ ప్రాపర్గా రాస్తున్నారా? Why? Because I'm moving the screen fast. I don't know whether you are following or not. So just ask me to hold for some time. If you are unable to write within the time, just inform to me. Next, third one. What is it? Basic salt. Just quite opposite definition. This is the salt which releases OH minus ions except in its first ionization. We can write the definition like this, which releases OH minus ions except in its first ionization. That is the basic salt. Again, you can take examples, few of examples for the basic salts. This one, like this you can take. Excellent. These are the few examples which comes under basic salts. Again, let us go with one explanation of this calcium hydroxychloride, and do in the first ionization, you will get calcium hydroxide. This is overall, I can write plus and Cl minus. This is the first ionization. In the second ionization, this cationic part further can undergo ionization. In the second ionization, now it can releases this OH minus. You will get a calcium 2 plus and OH minus. In the second ionization, it releasing the OH minus, so hence we can say this compound is a basic salt. Like that we can explain for remaining also. And the next one, mixed salt. Fourth type, this is fourth type. Mixed salt. Again, what is a mixed salt? We can write the definition like this. The substance which contains two or more different cations and one anion. Substance which contains two or more different cations and one anion. That is a mixed salt. Or we can define in another way. So this is with respect to cation. Now with respect to anion also, it may have more than two anions and one cation. Again you can define in another way. The substance which contains two or more different anions and one cation. In place of anion, we are writing the cation. That's it. That is called mixed salt. We can take one example on here. Generally, this is possible with polyprotic acids or polybasic compounds. Let me take oxalic acid for example. One of the part is attached with one of the carboxylate group is attached with potassium and one is sodium. This one. See, this is a place and this is place. Or you can take like this. This is also example. Calcium, this is cation and these two are anions. So in case of sodium potassium oxalate, and we have the anion, oxalate anion, this it can split like this. It can give COO minus COO minus. Only one oxalate means overall COO2 minus will take, and one potassium, one sodium. So, two different cations and one anion, and similarly in this case it can produce calcium 2 plus, apart from that OCl minus and Cl minus. Now you can say two different anions and one cation. Like this type of the salts we can call them as the mixed salts. Following in all of you classifications. So, that is about the mix. Next we have the double salt. Then what is a double salt? Two no, 2 moles of any salt is not correct. If you take any salt, means sodium chloride, we cannot say sodium chloride means it is only 1 mole or 2 mole, 3 moles. It may be anything. Overall sodium chloride only, one compound. Two types of salts, not two same type of salt with 2 moles. It is a combination of 2 or more simple salts, and the type of salts we can call double salt. Combination of 2 or more salts. Mostly we will take a combination of two normal salts. Here salt also you can take. Simple salts. And they are the double salt. Examples for this double salt: carnallite. You take potassium chloride 6H2, and this is called carnallite. So, this is a carnallite is made by taking potassium chloride, one simple salt, magnesium chloride, another simple salt. If you mix these two to the water, and if you make a crystallization, and you will get this potassium magnesium chloride 6H2O, one kind of double salt. Another examples you can go with Morse salt and alums. Alums also comes under double salts. Morse salt we have taken already. Ammonium sulfate, ferrous sulfate, 6H2. Again you mix ammonium sulfate, one salt, and ferrous sulfate, another salt, and you make a crystallization process, you will get this salt. Alums, potassium sulfate, aluminum sulfate, 24H2O. This is called potash alum. This is also double salt. The last type, complex salts. So, generally complex salts means similar to the double salts, but they cannot undergo complete ionization, whereas this double salt or other salt, they can undergo complete ionization, and these are the special type of the salts. So, they will not undergo complete ionization. The salt which does not undergo complete ionization is called complex salt. So these salts also generally can be made up of by addition of 2 normal salts, 2 simple salts, but after formation of that complex salt, no ionization process. Now let me take one example here. Potassium ferrocyanide, a compound. So this compound, if you do the ionization, so here you will get the ionizable ions like this. The potassium can undergo complete ionization, it can give 4 K plus ions, but if you see the part which is present within the closed bracket and this iron and cyanide, they cannot split further. There is no ionization of further iron and cyanide. So we can see together. And this is total as 1 ion. So iron hexacyanol is in the total 1 part and potassium is 1 part. So there is no further ionization. This one, if you want to see, no further ionization. Here. But whereas in case of double salt, just now we have taken previously, we will come back to that. If you see ammonium sulfate or ferrous sulfate, whatever it is, just if you do ionization, you can see completely a formation of ions, individual ions. Ammonium you can see separately, and iron 2 plus you can observe, and SO4 2 minus you can observe. And if you do any test for the identification of ions, you can identify the presence of ammonium, iron 2 plus and sulfate ions in this solution. And if you do any qualitative analysis, but whereas in this case, if you take this salt and if you analyze the qualitative analysis, if you do the identification of ions, we can see only the presence of K plus ion. You cannot observe the presence of iron 2 plus or cyanide ions. The test will not give. You will get negative test there. So that is the one. Complete ionization, or we can say partial ionization sometimes. But in detail about this complex salts we will discuss in the 12th. We have complete one chapter is there, complex compounds or coordination compounds. So in detail about their properties, formation, geometries, colors, everything we will study. That is also very important chapter in the inorganic, and also there is a weightage chapter. I told you already in the first class itself about the complex salts. Okay, this is some classification based on what? Based on the chemical nature. We will take up a few examples here regarding this, then we will come back to the second kind of classification. A few basic type questions now. Just tell me what type of salts they are. If I give one compound like this, so there are 4 salts are there. Just identify among these 4 the acidic salt. Identify the acidic salts. The first one, NaH2PO3. In the first ionization, what happens? Na plus H2PO3 minus. Again this H2PO3 minus can give H plus HPO3 2 minus. So we are getting the H plus in the second ionization. So whatever it is, except in the first ionization, if it gives H plus, that's it, we can say that is the acidic salt. So we can say first one is the acidic salt here. Is it none? Now come to the second one. In its first ionization, you can see Na plus H2PO2 minus. Again this H2PO2 minus, this is in the first ionization. Second ionization, is there further ionization of this H2PO2 minus? HPO2 2 minus. Is this possible? Just we can recollect the yesterday's class. What about this H2PO2? Here in case of, actually this H2PO2 will come from the acid H3PO2, isn't it? So H3PO2 is monobasic acid. It releases only one H plus ion. That one H plus ion can be replaced by the sodium. It can form this salt NaH2PO2. So only one sodium can replace. Further ionization of this H2PO2 minus is not possible. So this is not possible. There is no further ionization. Means what? It is only simple salt, not acidic salt. Understood? Again, the third one. In its first ionization, you can see the formation of Na plus NaHPO3 minus. Again, this can further undergo ionization. Again, it can give Na plus Na2HPO. We will get HPO3 2 minus. Now again this one, if it undergo further ionization, we will get H plus and PO3 3 minus. Again, is this possible? The further ionization of HPO3 2 minus, is it possible or not? No, not at all. Why? Because here hydrogen is directly linked to the phosphorus. Again, just you recollect the yesterday's the structures of H3PO2, PO3 and PO4. So again, it is not releasing H plus ion, so this is not acidic salt. Again, and the last one, anyhow there is no hydrogens in Na3PO4, so this is also not acidic salt. So which case we are getting? Only in the first case. Only the first one is the acidic salt. The remaining three are not acidic salt. Just we feel that they are acidic salts, but not. We'll take these here. These structures of H3PO2, H3PO3, H3PO4. Okay, na? Here H3PO2 structure already we wrote like this. And H3PO3, and H3PO4. Okay, now generally this if we treat with NaOH, what we will get, Nana? And this OH hydrogen, they can be undergo neutralization, one sodium can attack here. So mean the actual structure is like this. ONA, and this compound can undergo ionization and it can give Na plus and O minus in the first ionization. Let it be. Come back to this one. Again you add 1 mole of sodium hydroxide to this one. What compound we will get? So there are 2 OHs, 2 hydrogens are there replaceable, but out of 2 only one is replaceable. Only one can undergo replaceable. Both can undergo, but here we have only one sodium hydroxide. Then it can form the salt like this, right? And in this case, if you see the third one, again if you add 1 mole of sodium hydroxide to this, what salt we will get? So any of the hydrogen can be replaceable here with sodium. Now this compound, if you do the ionization, we will get O minus and Na plus, right? Here further splitting can take place. Is there any other possibility to give H plus ions in this case? H3PO2 is a monobasic acid, right? It can release only one H plus ion. So that H plus is replaced by the sodium. Come to the second case, Nana. Again this is a compound now, NaH2PO3. 3 oxygens are there, 2 hydrogens are there, 1 sodium, and this compound can undergo further ionization. It can give minus and plus in the first ionization, and still there is a chance to release H plus ion, right? And this compound is having, apart from this Na plus, it can release H plus also, means it is an acidic salt. Similarly this one, here Na plus and O minus, and this can releases 2 more H plus ions further. So again this is acidic salt. But whereas in the first case there is no further replaceable, further ionization of the H plus ions. So no further ionization can take place, only one ionization. Here hydrogen, phosphorus. So if it releases O minus and Na plus, that's it. You can see these 2 ions only. There is no further breaking of phosphorus hydrogen bond. Understood? But whereas in this case, anyhow you are getting these 2 ions. Again this one, this negative charge, again H plus can replace from here. So you will get HPO3 2 minus here. This is possible. Come back. In this case, the first one, NaH2PO3. So it will give Na plus H2PO4 3 minus. What is the structure of H2PO4 3 minus? So this is the one. Again we have one more hydrogen here to ionize it. So that further can ionize, it can give HPO3 2 minus. So we can say this is acidic salt. But that is not possible the remaining cases. Understood? All of you understood here? Still any confusions, Nana? So like this, they'll ask the question sometimes, that you should remember, especially about the acidic salts. That also with respect to H3PO2, H3PO3 and H3PO4. So based on these 3 acids and the corresponding salts, and they'll ask which is acidic or which is a normal. Again you have to go back, Nana. Still if you have confusion, just go back to the structures of H3PO2, H3PO3 and H3PO4. There again type of acidic basicity. What is the basicity of H3PO2, PO3 and PO4, and what is the reason? means structure. So very important. Okay, this is one type of classification. Second classification, the second one, based on the strength of acid and base. Based on the strength of acid and base. And again we can classify here, there are 4 types based on the strength, and one by one. First one, this is a salt of strong acid, strong base. Salt of strong acid, weak base. And the third one, salt of weak acid. And a strong base. And the last one, salt of weak acid, weak base. Means how the salt of strong acid, strong base means if you take one strong acid and strong base, if you mix it, undergo neutralization and they can form that type of salt. So like that. So the examples of these salts, their formation and properties, that better to discuss in the next class anyhow.